linked list. Okay, so yesterday little bit we touched with delete and search by point of view. So as a practically we have gone through. Okay, we have seen some programs. Okay, there today we'll complete that task. Okay, so anything is remained over there, and then we'll move to the doubly linked list. Okay, so that will have. So any doubt in the part of the hacker rank that you have solved yesterday?
No, sir.
Okay, I hope everyone have completed the task. Okay, so of hacker rank. If anyone is remained, just let me know. Okay, you have to compulsorily finish that. Okay, so I think the time is already over. Yesterday 9 p.m. I kept over there. Okay. Okay, so with the pin drop silence, I will expect everyone have submitted. Okay, so now we just gone through this. The linked list we have seen so graphically, and now we have already solved the examples over there. If you have solved promptly without copying anyone else, so you will get to know what exactly it is. So the first we have a node, so that will have one as a data, okay, and another one as a pointer. Okay, so these are the two parts we have in this case. Okay, so that we have, and every node is next node is connected to the previous node, so with the pointer. Okay, so that we have, and for creation of this pointer we can use the structure. Okay, so that struct node we have created. Otherwise we can create a class node also. Both way it is okay. Okay, somewhere you'll get online, if you search for some codes, they will found the class node. Okay, but already as the first practical we have completed, so some of you have requested to means that not to what I can say, not to more focus on C++ concept, because that will be already covered in OOPS. Okay, so we'll see after 2-3 practicals we cover up. Okay, so then we'll directly add much more contents of the C++. So that will be okay, because that at that level you will come across 2-3 practicals of your OOPS also. Okay. So I don't waste much time on this. Okay, so this we already gone through. Okay, so this program we have seen to work on singly linked list. Okay, so that will have your node. Again, the thing I am telling you. Okay, so somewhere you'll get the name as start, somewhere you'll get the name as head. Okay, so but the terminology will keep head always in mind, but don't confuse. Okay, if there is start also. Okay, the terminologies you have to means keep in mind. Okay, so there will be one node which is referenced by some head node or start node. Okay, so because that then only you'll able to traverse through this linked list. Okay, so otherwise it's not possible to traverse this linked list. Without head node we are not able to jump anywhere. Okay, so likewise already we have seen this is an array. So in an array, so I have to start only with the what we'll say zeroth element of that array. So without having that zeroth element, we are not able to start over here. Okay, so that you just remember in your mind. Okay, so this is the singly linked list functions we can say. Okay, so one is insert function. So we have insert begin, insert at a specific position, insert at the last position, delete at the position, sort at the sort that particular whole thing we have. Then we'll have search operation, we have update operation, we have reverse operation. Okay, we have display operation. So these are the different operations that we have in a linked list. So already we have covered this insert operation. We have inserted at the what we'll say last node. Okay, we can insert in begin also. We can insert at a particular position also. Suppose there is a linked list which has 10 elements. Okay, and there is a requirement. Okay, so I need to insert at the position number 3. Okay, so then also can you tell me roughly how we can do this? Suppose there are 10 elements in linked list and I have to insert the third node. How we can do this? Yes, anything that you can tell? Yes or no? Okay, so these are my 5 nodes. Okay, so that are connected. Okay, so in that node I have to insert the element at the third position. So how we can do this? Yes, how we can do this? Anyone? Am I audible?
Yes, sir. Yes.
Okay, just tell me how we can do this. Okay, so we have 5 elements now and I have to insert at third element position. Okay, how we can do this? Suppose this at this position I have to insert. Okay, so this is my position where I have to insert the things. So how we can do this?
Sir, we will traverse till second position, and we will give the value of the third node which we have to insert to the next of the second.
Yes, yes, correct. Okay, so we'll just do that. Okay, so it's very simple actually terminologically if you're correct. Okay, so what I will do, I will create a new node. Okay, so this is my new node which is created. Okay, so I will have a temp. Okay, so temp is starting over here. So we'll increment the temp till we'll reach to second position. So this is my second position. So temp will reach to the second position. Okay, so now just tell me which pointer we have to move for which. Okay, temp next will be what now? Temp next is new element. Yes.
Yes, sir.
Yes, sir. Temp next.
Okay, so before temp next, what I will do? Okay, so I will take. Okay, so temp next is this arrow. Okay, so if I made temp next is equal to this element. Okay, and then this element next I have to do what?
This elements next you have to do with the fourth element.
Yes, so there will be one extra element we need to take because
Yes,
I will take x is equal to temp next. So x is my dummy element. What I can say, x is equal to temp next. I can say. Okay, so I'll just write t next. Okay, x is equal to t next I can say. Okay, so like I will write. Okay, so my temp next is equal to new element and new element next is equal to x then. So x is pointing over here. So now this new element is inserted in this list. Okay, so that we can say this is inserted at a particular position. Getting?
Yes.
Yes, sir.
Okay, so and insertion at the last and what we'll say insertion at the last and begin you did into hacker rank. Yes or no? That is there, na?
Yes, sir.
Okay.
Yes,
So again,
sir.
how to insert at the last? It's very simple. Just start with the temp, create a new node like over here. Okay, so new node is created. You traverse your list until you will come across the null element, and only the last element you have to put to the this particular thing that we have. Wait a minute. Okay, so that is to add the element at the last. I think you have work on that. Okay, so insertion at the last. So can you tell me how we can delete that the last position element?
Sir, in a while loop till temp of next is not equal to null, we'll traverse the linked list and then we'll delete insert at the last element.
Yes, yes. So, so yes, as she told. Okay, so if we have a linked list like this, okay, so I'm not going detailed in programmatically. We have learned actually. Okay, so yesterday we have taken the syntax of program also, and in lab also we'll do that programmatically. But conceptually, it should be clear to you. Okay, how we are doing this. So suppose this is my linked list, which will have 4 nodes. Okay, so this is one node is connected to second, second will be connected to third, third will be connected to fourth, and fourth is a now last node. Okay, so this is null node. Okay, so that we have. So if I have to delete the 4th node, so what I have to do? I have to take one temp element. Okay, so this temp we can have over here. Okay, so that temp I have to take. Okay, so temp I have to traverse till I will reach to a node. Okay, so whose next is null. Okay, so I will reach to a node whose next is null. Okay, so once we reach to the node, okay, so I will write the code actually, so that will help. Okay, so I hope other basic part is clear to you. Okay, so temp is equal to head I will do. Okay, so what I will do while, what I have to write?
temp next not equal to null.
Okay, temp next not equal to null. Okay, so that we have. So once it is like this, so it will start from this temp. Okay, so its null is not null, its null is not null, its its next is not null. Okay, but its next is null. So now where is temp now? At which position?
Tail at last position.
Okay, so that is at last position. Temp is here. So how we can delete this? Is it possible to delete this element?
Assign करून द्यायचं.
Yes, so what I will do now, what we can do instead of temp next is null. Okay, so is there any other thing that we can do to work on this? Okay, so temporary variable. So can I write? You can do by your own. There are multiple ways. Can we do like this temp next text?
Yes sir. हा सर रेस्पॉन्स करू शकतो म्हणजे एक अजून एक पॉइंटर क्रिएट करू. हा सर.
We'll make x is equal to temp next. Okay, so now your temp will be at this position. Okay, so temp will be at this position. Okay, and your x will be at this position. Correct?
Yes, sir.
Yes.
Okay, and why I need to create x? I can directly make na temp next equal to null. Yes or no? But why we need to create the temp then? Sorry, this x element then.
So delete करता नहीं.
Yes, because that should be deleted from the memory. Always remember. Okay, so somehow if you have assigned memory to some variable, that should be deleted from, because it is a pointer. It's not like a normal variable. Okay, so that gets deleted. So we have to delete that. Okay, so what we'll make now? Temp next. What I have to write? Temp next is equal to null. Okay, and I'll write delete x. Getting? So this is the code to delete the last element in that. Okay, in between deletion we have already done in last lecture how to delete the element which is in between. Okay, so just to have switch the pointers over there. Okay, so this we have. Okay, we'll have display already. We have gone through. Sort, how we can sort? The same thing, bubble sort or any sort you can use. Okay, so sorting we can do. Okay, so we'll see sort and reverse, that we'll see once we reach to that point. Okay, so creating a node, that's very simple. Okay, only you just do like this temp, you just create. Okay, and temp info will be value, temp next is equal to null, and you have to return temp. Like that you will work on that. Okay, so this will be a linked list that we have. Okay, so we have a set of characters like this, a linked list of characters you have to create. Okay, so instead of int data, we'll see a character data. Okay, then we have a sorted set of elements also that we can put polynomials also. Linked list is very much been useful in working with polynomials. Okay, so that we have likewise. Suppose the polynomial expression is like this. It is we can say that we may come across after it's an application of linked list. Okay, so my polynomial will be 2x square. Okay, so 2x square plus 3x. Okay, 3x plus 2. Okay, so that is my polynomial, I can say. Okay, so now what we have in this, I will have everywhere one what we'll say constant I have and one exponent I have. Yes or no? Hello. For every element we'll have one constant and one exponent. Yes.
Yes sir.
Okay, so how we can create now? I will create a node. Okay, struct node I will create like this. Okay, so just a minute. Okay, so I will create a struct node. Okay, so struct node. So data will be of 2 now. Okay, so data will be now integer constant and integer coefficient. Okay, so that will be a data we have. So it will be for this particular polynomial will have integer constant. Okay, and integer exponent or what you can say anything. Okay, so that will be your struct node. So we can write struct node. Okay, so that will be there. Okay, so and you have a next. Okay, so that will be node star next. Okay, so that pointer should be there. Data you can increase. Here you can put anything. Here you can put structure, anything. Okay, so now with the help of this, it's very efficiently we can add it to what we can say will work on means this polynomial calculation and all with the help of this structure. Okay, so only thing is that this node now become like this. Okay, so it will have 3 parts. Okay, so we can say like this. This particular node will have 3 parts. Okay, so like this. Okay, one part is for data, another part is also for data, and the third part is for pointer. Okay, so likewise we'll able to store the polynomial in with the help of linked list. Getting? Hello?
Yes, sir.
Okay, So these we can store like this. Okay, so this is given over here as an abstract view, but we can work on that. Okay, so now different operations on list. So insertions at the head of the list or at the tail of the list you can insert. So we have worked on at the tail of the list. Okay, so whatever the program will did, so that we have worked on tail of the list. Head of the list we can work also. Then again inside the list you can work as some designation position. Okay, so this is my first operation that I have to perform on list. Okay, so second operation is search. Okay, so in that we'll search for an item in the list. Okay, so the item can be specified by a position. Okay, so or by some value. Okay, so suppose we can, like already we have seen an example, I have to place the element at third position. Okay, so that we can say I have to search the element at the third position, I can say. Otherwise I will search a number which has a value 11. Okay, so both way will work. Okay, so that search we can opt with. Okay, so that is search operation. Delete already we have did. Okay, search also we did in last lecture. Okay, search and locate the element, and the same thing will remove. Okay, size will be there. So how we can find out the size of the linked list? Yes, how we can find the size of linked list?
Sir, will
traverse करत जाणार शेवट null not equal to null पर्यंत and n plus करत जायचं. N is equal to 0.
Okay, so we have to traverse till we'll get the null, and we'll set one counter, so that will be incremented until we'll get the null position. Okay, so I think that's very simple. So by which way we'll calculate the size? How we can check whether the list is empty?
If head equals to null.
Head.
Yes. So if head is equal to null, so then we'll check it's empty. Wait a minute. Okay, so now how we can check is empty? If head is null, so we can say it is an empty. Yes or no? Yes.
Yes, sir.
Okay, so head is null, that we can say. Then we'll see one by one. We'll quickly go through this because we have implemented insertion. So insert data at the head, so that we can have. Suppose this is like we have. Okay, so A I need to insert, so that will be like this. Okay, how we can insert at the head? So just a very simple. Okay, what I have to do? I have to make what I can say. Suppose my A node is there, so A next will be. What is A next will be? It is head next. Yes?
Yes, sir.
A next will be head next. And what is head next?
Null.
What is head next? I have to insert at the initial. This A to be added at the initial position. So what is head next, or what is head? Head next is equal to A. Yes?
Sir, head next. Yes, sir. Head next is equal to A.
Head next will be A because A is added. So what we'll do now? This is my head. I will create one A node over here. Okay, so like this. Okay. So now this A next will be head next. So head is pointing now this head next. Okay, and head next will be A, or head will be A now. Better way you'll make head is equal to A. Getting? Yes?
Yes, sir.
Yes, sir.
Next we have to manage. You can directly make head is equal to like this. Okay, head pointer is equal to new pointer. Okay, so that we can directly make. Rest of the thing you'll just work on that. Okay, so insert at the begin. So that is the code. Insert at the tail, that we have discussed already. This is my A node. So that I will insert at the tail. Okay, so after insertion, so it will look like that. Okay, so you have to find the last position and you have to put like this. Okay, so this will do. Okay, so this is the code. Okay, inside. So that we'll did in last what we'll say lecture. So this is put like this. Okay, so you have to search and you have to put like this. Okay, so that we have. Okay, delete the head item. So how to delete the head item? Just we'll make X is equal to head. And we move like this, like X equal to head will make. And what we have to do now? I have to delete the head element. So I'll make X is equal to head, and I will do head is equal to head next. Will it be deleted? Yes. Will it be deleted? I will make X is equal to head. So suppose this is my list. Okay, I have to delete this. Okay. So what I will do? I will assign it X. Okay. And I will make head is equal to head next. So head will be pointing to this position now. So now this is my new head, and I will delete this X. So will it delete this?
Yes, sir.
Yes.
Yes.
This, by this way we'll delete. So list after deletion it will be like this. Okay, so this is the dereferenced. This is called the dereferencing. Okay, so you are not referencing anyhow to this node. Okay, but we have to delete that. Okay, that you must remember. If it is not deleted, no issue, our program will run. Okay, so it will not come across our picture, but again that 4 bytes of memory, it is again engaged in your program. So always once you dereference the nodes, you have to delete. Okay, tail element is very simple, that already we have seen. So just you have to dereference that. Okay, anything we have to delete inside. So suppose second element you have to delete, so you have to just pass on the pointer to the next element. Okay, so that is deletion. Okay, delete element. So that we have, I will share this PPT to you, so you just go through the code and all. Okay, so but that code we already discussed also. Size is there, so size, you know that we'll just move to the last null element and we'll increment the counter, and is empty, we'll just check the head pointer is null, so then we'll say it is an empty thing. Okay, searching will be there. So suppose you have to search something, so searching will be done. Okay, so if it is found, you just break the loop and you just come out of that. Okay, so now what is the time of the operation, okay, required? So time to search is O of L. We can say where L is the relative location of that. Okay, so element. Okay, so what we have, the time is O of N. If it is worst case complexity, we can found. Okay, and average case complexity will be anywhere between O of N by 2 to O of N. Okay, so that will have time complexity of this. Time for the removal, again O of N. Okay, and if it is found at the first position, that is O of 1. Okay, time for insertion at the position which is at the last, so that will be O of N. Okay, so that we can say the insertion. So time for size is we can say O of 1, and time for is empty is also O of 1 if it is only an empty part we have. Okay, then how to update? Update is again the same thing. Okay, update is again same thing what we did. Okay, so we have to reach to that node. Okay, this is my temp, I will reach to that node, and if the value is same, so I have to just update the value at that node. So suppose I will replace it with 2. Okay, so that we have update part in this. Okay, so now how to reverse? Okay, so that's we can work on. Okay, so how to reverse? So anyone have gone through how to reverse, how we can reverse the linked list? Okay, so we'll just go with this code. Okay, we'll just see how to reverse. So suppose these are 3 nodes I have, so we'll reverse this node. Okay, so this is my first node. Okay, this is my second node, and this is my third node. Okay, so these 3 nodes I will have with me. Okay, so it will have some data. Okay, so and a pointer to the next element. So now this I have to reverse. Okay, so this is like this. Okay, and this is connected to this node. Okay, so to reverse we can say, okay, so okay, we'll work on this start is null, so we'll return that it is empty. Okay, so if it is null, we'll return is empty. Okay, so we'll keep pointer 1 to start, so it is P1 I can say. Okay, so P1 is pointing over here. Okay, P2 is pointing over here. Okay, so that we have. Okay, and P3 is pointing over here. So there are 3 pointers we have taken. So, okay, P3 is pointing over here. Okay, so likewise there are 3 pointers we have. Okay, so we have seen P1 is equal to start, P2 is equal to PTR1 next, and P3 is equal to PTR2 next. Okay, so now we have to reverse. So what is done? PTR1 next is null. Okay, so its next is made as null. Okay, so here it is made as null. Okay, PTR2 next is made as PTR1. Okay, so PTR2 next is made as PTR1 over here. Okay, so that is the first operation, because once you reverse, so this will be null. Okay, the first element always null. Okay, because that will become now a last element. Okay, and the same operation we have to perform this while loop till PTR3 is null. Okay, so PTR3 is over here. Okay, now it is pointing. So again, what I am doing, PTR1 is equal to PTR2. Okay, so PTR1 that is P1 now shifted over here. Okay, P1 will be over here, and P2 will be now PTR3. So that P2 will be over here shifted. Okay, and again P3 will be shifted to the next element. Okay, like that it will shift to the next element we have. Okay, and again we are making PTR2 next is equal to PTR1. So again we are making like this. So these are like pointers are updated. So this will kept as it is. Okay, so this will be null. Okay, and continuously the next element will be point to the previous element. So that will did over here, and finally we'll come across the stage where the PTR3 is equal to null. Okay, so PTR3 will reach to the next thing. So at that time PTR2 will be the last node. Getting? Hello? Yes or no?
Yes, sir. Yes.
Okay, so ptr2 be at the last node. So in that case, what it will be having? So ptr2 will make it as head. Okay, so the whole list will be reversed in this sense. Okay, so that will be the reverse operation we have performed. Okay, so if you require that explanation in detail, so we'll just see. Okay, so I'll just quickly take that reverse operation. Okay, so if you have any doubt, you can tell me. Okay, so I will take few nodes. Okay, this is my first node. This is my, we'll see reverse of 5 nodes. Okay, this is my second node. This is my third node. This is my fourth node, and this is my fifth node. Okay, so we'll have forward link. I will give it some yellow color. Okay, so this is my actual link we have. Okay, that is actual link we have. Okay, so I will make like this. Okay, again we'll connect this element over here. Okay, again we'll connect this element over here. Okay, and this is my head node. Okay, so that initially we are making this as a head node. Okay, so we'll write the code now. Okay, how we can do this? Okay, so very simple. We'll have 3 pointers. Okay, so suppose that is node star p1, star p2, star p3. Okay, so these are the 3 nodes I have. Okay, so what I will do now? Okay, so p1 is equal to head. I'll write head. P1 is equal to head. Okay, then p2 is equal to p1 next. Okay, and p3 is equal to p2 next. Okay, what we'll have now? So p1 will be now here. Okay, we'll just take like this. Okay, so p1 will be over here. So I will write p1. Okay, p2 will be over here. Okay, and p3 will be over here. Okay, so now how to reverse? Okay, so now, but after the reversing of the list, which will be the last node? Which will be the last node? Okay, once you reverse the list. Okay, which will be the last node?
Head.
Head is the last node, means P1 is last node. Okay, so P1 next will be what then?
Null.
Null. Okay, because this is last node, so we'll keep that is null. Okay, so that will make a null. So just this consider green color over here for that purpose. Okay, so we'll just see now. Sorry. Okay, so what I will make P1 is equal P1 next is equal to null. Okay, so now that become null. Okay, so this we have done. Okay, so I will make P2 next is equal to what then? P1. Yes.
P1.
So P2 next is P1. So this is for sure. So we'll made this link like this. Okay, P2 next is equal to P1. Okay. So now what we'll do now? Okay, so it will be like this. Okay, so now we'll repeat this procedure now. Okay, P2 next is equal to null. Sorry, P1 we have did. Okay. So what I will do? I will repeat this procedure again. Okay, so we'll have like this. Okay, so what I will do now? While okay, P3 not equal to null. Okay, so P3 not equal to null. What I will do? Okay, so again we'll make P1 is equal to P2. P1 next is equal to P2. Okay, then again P2 next. Sorry, P1 is equal to P2. Sorry, P1 is equal to P2 next. Okay, P1 is equal to P2 next. Okay, P2 is equal to P3 next. Okay, and we'll just make P2 next is equal to P1. Okay, so that will make. So what will happen? Okay, continuously it will move like this. Okay, so what will happen? Again, this P1 and P2 now shifted. Okay, so what we did, I'll just remove this. Okay, so we'll just remove this P1 from over here. Okay, so P1 will be updated to P2, P2 will be updated to P3, and P3 will be updated to later point. Okay, so now P1 will be over here now. Okay, P2 will be over here now, and P3 will be over here now. Okay, and what we did? Okay, what we did? We did like this. P1 is equal to P2 and P2 next is equal to P1. Okay, P2 next is equal to P1 again we did. Okay, like this. Okay, so and this is already pointing. So this already link is removed because we have pointed this to the previous node. Okay, so this is also removed because we have made it null. Okay, Next thing what we'll do now, this will again iterate. Okay, so again it will make it next. Okay, so this will be not P1 now, so again it will be iterating. Okay, so this is now P1 and this is P2 and next is P3. Okay, so again we'll have this P1 is over here, P2 is over here, and P3 is over here. Okay, so that we have. Again we'll make this, and again we'll make P2 is equal to next, P2 next is equal to P1. Again this is updated. Again P1 is already shifted previously, this link is already deleted. Okay, again it will update. Okay, again P1 will not be here now. Okay, so P1 is updated with this. Okay, like this. Again this will be removed like this. Okay, so this is P1, this is P2, and the next is P3. Okay, one step I think remained. Yes, this is P3 is equal to P2 next is remain in this loop. Okay, so now we have reached, that is P3 is null. Okay, so there is nothing over here, so this P3 becomes null. Okay, so we reached over here. Okay, so again the same thing will work on this. So this will align like this. P3 becomes null. Okay, so once P3 becomes null, okay, so what will make, P2 will make as a head node. Okay, so P2 is equal to, sorry, we will just make head is equal to P2. So head is now pointing over here. Okay, so this head will be now pointing at this position. Okay, so this now whole list is reversed. Getting? Yes or no? Hello? Getting how it is working?
Yes, sir.
Okay, so I hope it's clear to you. You just practice more on this, so that will help you. Okay, so this is about reversing the list. Okay, display the elements you know already. Okay, implementation of an item. Each item is a collection of data and pointer fields, so should we work as a node. Okay, so that we can work on. Okay, so we can have the class also in that. Okay, so we can create a functions in that class like get next, get data, set next, set data, like that. Okay, so this is class that we'll see once we'll reach to this point. Okay, so in class what we'll do, so same thing, we have a structure, we have these things. Okay, so data and a node we have over here. Along with that, what are the functions we are writing outside the struct? Okay, so that we are putting just inside the struct. Okay, so this is called as an abstract data type or abstract representation of your list. Okay, so that we'll see in programming also if we got time. Okay, so we'll add this C++ concept over here. Okay, this is the representation. Okay, so implementation you can do with this. Okay, so this is a class representation of the same. Okay, so that will do practically, because everything is same, only you have to declare that in the fashion of the class. Okay, so that we have. So this is about singly linked list. Okay, so that we have in this what we'll say particular point of view. Okay, so as per the discussion of this. Okay, so any doubt in this singly linked list? Hello, or anything that you require from me? So that is to be discussed as a program in this case. Yes. Yes, tell me. Is it clear to everyone, singly linked list? Yes or no?
Yes, sir.
Okay, so I hope it's clear. Then, okay, so we'll move to the doubly linked list then. I'm teaching in reference with that everyone is listening actually. So hope you are listening those parts. Give me a minute. Yes. so now, okay, so we'll see some sort of doubly linked list concept. Okay, so once it is done, so there are only 2-3 points remained with this. Okay, if you are practice much regarding to singly linked list, okay, so that will help you for doubly circular linked list. Okay, so only on the basis of singly linked list we have 2 more linked list. Okay, so that is doubly linked list and circular linked list. Okay, so if you have very much good concept, I can say, of your singly linked list, okay, how the pointers are working and how it is operated. Okay, so then it's very efficient to work on doubly linked list. Okay, so hope this much is clear to you, part of singly linked list.
Yes, sir.
So quickly we'll just go through the doubly linked list concept. Okay, so how it is working. Okay, so I will just open one diagram. Okay, so screen is visible. Hello.
Yes, sir.
Okay. And again, I will open that hacker rank. I'll just see how many of you submitted. Okay, where it is, the created challenge, anyone knows? I need to search actually. Okay, so this I think assignment. Okay, so 76 students login count this. Okay, so almost I think all of you have submitted. Okay, no issue. I hope you have submitted. So anyone is remained, so you just tell. So if anyone wants to reopen that link, okay, so I will open that link again. So for someone who is not completed, okay. How many are there? So okay, I hope submitted much of them. Okay, so what is it, Koshlesh, Mandar? Okay, so I think you are not submitted. Yes, these 5 remaining below, 5, 6. Okay, then I will just check and I will update. Okay, so but if you are remained, you just tell me if it's there. Okay, remain. Okay, then we'll start with the doubly linked list. Okay, so doubly linked list is like this. Okay, so like we have a singly linked list. Okay, this is my node. Okay, this is my first node. This is my second node. Okay, this is my third node. Okay, so in singly linked list, what we have? So in singly linked list, we have only next pointer with this. Okay, so this is my next pointer to this node. This is my next pointer to this node. Okay, so again, I will have an extra node over here. Okay, like this. Okay, so this is my next pointer over here. Okay, so I will have head node. Okay, so suppose there are a few numbers in that. Okay, so suppose this is, I can say, value 2. This I can say the value 3. This I can say the value 4. This I can say the value 5. Okay, so if I have to print this in reverse way, so it's very tedious task. So already we have seen, so reversing the things is very difficult. Okay, and that whole list we have to reverse, then only we'll get the data in reverse order. Yes or no? Hello.
Yes, sir.
Okay, so it's very difficult to work on this both approaches. Suppose we have a list of 100 elements. Okay, so suppose I have to go to search the 90th element, so that will be again I have to traverse all this. Okay, so there is one way, okay, that which we can again come with the reverse order also. Okay, so this is called as the doubly linked list. Okay, so here as per we have a forward links, okay, which we are giving with next. We also have a previous links over here. Okay, so that will have that is connected to the previous. Okay, so now tell me which is head node and which is tail node, how we can identify which is tail node and which is head node. Any property that you'll get, this we call it as a head node and this will call it as a tail node. Tail means the last node. Yes. Okay, it's very simple actually. Okay, so the element whose next is null, so that is tail node. Yes. An element whose previous is null, that is head node. Yes or no?
Yes, sir.
Okay, that's only okay. So that's we have. So for node creation, okay. So what sort of code we'll do now? Okay, so it is struct node. Okay, so it is int data. Okay, so there will be 2 pointers. Okay, so that is node star next. That is node star previous. Okay, so these are the 2 nodes that we have. Okay, so every node will have 3 parts now. Okay, so like this. Okay, so this is for previous, this is for next. Okay, so this is for previous, this is for next, and the middle is for data. Okay, previous, next, and middle. Okay, so previous, next, and middle. Getting, so this is the representation of doubly linked list. Getting clear? Hello. Yes, it's clear or not clear? Partially clear. How it is?
Partially clear.
Okay, so what is not clear that you tell, so that I will explain again. काय नाही कळालं ते सांगा, म्हणजे थोडं मला सांगता येईल. Yes, just give me a
हेडचा पुढचा पॉइंटर आहे ना सर त्याचा.
हेडचा
सर नाही सर, म्हणजे ते एक नलला पॉइंट करतो ना, तो लास्ट एलिमेंट टेल वाला.
yes, Purnesh, what you are asking? For head you are asking, na?
Yes sir, yes.
Okay, just consider these as a single node. Actually, every node has 2 pointers. Like this is the previous pointer and this is the next pointer. So if I consider head, its previous is this pointer and its next is this pointer.
Okay, sir.
Okay. Like this it is. Okay, so it's not between 2. Okay, it's like this. Clear?
Yes sir, yes.
Okay, for that head previous is null and tail next is null. Okay, any other doubt or anything not cleared? Okay. Okay, can you put +1 if it is cleared? I will just check. Okay, how many? Because silence is very irritating to me. Okay, if you are not speaking anything, just give me +1 at least. Okay, so that I consider clear. Okay, so if it is count nearby 30, 40, so that will move forward. Okay, with the concepts. Okay, so and that also helped me how many. Okay, Shubham little. Okay, and don't hesitate to give your response. Okay, so it is always welcome. Okay, and anything that you know, new thing you are added, anything that new thing you need to tell, you can also tell. Okay, no issue. Okay, so this +1. So can I mark these many only present student? Because I think many are now idle. Okay, so they're just login and not replying. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. Okay. Attendance म्हटलं की पटपट येतात ना रिप्लाय. Okay, so Shubham, what's not understood? You have just said little. So any point that need to be discussed in detail?
नहीं सर, एक बार मैं थोड़ा प्रैक्टिस करूंगा सर, फिर डाउट आता है तो बता दो सर.
Yes. No issue. Okay. So now but I hope singly linked list is clear to everyone. Yes, singly
Yes, sir.
clear to everyone. Okay, so now we'll just see doubly linked list. Okay, so again I will just have this part. I'll just. Okay, so now we'll just create this particular doubly linked list. Okay, so now how the new node is created in doubly linked list. Okay, if we will consider the code, so it's very simple. So we'll have a new node. Okay, so it will be created as a new star new node. Okay, again we'll create new node is equal to new node. Okay, so that we can say. Okay, and we'll just create a new node like new node data is equal to 20. Okay, then how pointer will be set? New node next will be null. Okay, and new node previous equal to null. Getting? Okay, by this way we'll create a new node. Clear?
Yes, sir.
Okay, so now how to add that node into the current list. Okay, so now I'll remove this above part, so I hope it's clear to you. So we'll just go with one single node. Okay, so initially head is null. Okay, so we have head and tail both. Okay, so head is null and tail is null. Okay, so this is my new node which is created. Okay, so this is my new node created. Okay, so like this. Okay, so now head is pointing where and tail is pointing where? In this case, if we created this. Okay, head will be the same pointing to the same node and tail will be pointing to the same node. Yes or no? Because there is only one node.
Yes, sir.
Okay. So now if you have to insert again new node. Okay, so suppose this is new node we have, this is head we have. Okay, so again new node comes in a picture. Okay, so we'll create a new node over here. Okay, so this new node comes in a picture. Okay, so that we need to add. So what we do now in this case? Just tell me. आता कसं ऍड करणार आहे या नोडला, कसं अटॅच करणार? जस्ट टेल मी.
सर प्रिव्हियसला हेडने अटॅच करायचं आणि नेक्स्टला नल करून टाकायचं.
Okay, so the same thing we are doing. Okay, so head next is equal to new node, and new node previous is head in this case.
Yes.
Okay, and what is tail then? Tail will be again new node. So tail is pointing over here. So tail will be moved to this position. Clear? And this next is already
Yes, sir.
This next is already null here. Okay, so this next is null, and this previous is null. Okay. So again, if you have a new node again, okay, so that is created like this. Again, linked list programming is simple. Okay, so that will take in practical also. We have a doubly linked list. Okay, so no issue. But conceptually, you must create clear. Okay, so now I have head at this position, tail at this position. Okay, so how we can do this now? Okay, so now if I have to insert at the tail, is there any need for going from head pointer? Because we have already tail over here, na?
Yes, sir.
Okay, so how we can do this? This is my new node now. This is my new node. Okay, so how we can add this new node to tail? Okay, so as a program, if you have to write, just tell me. What is tail next? Sorry, what is tail now? In this case, if new node arrives, okay, so I will make tail next is equal to, sorry, tail next is equal to new
node. Yes, sir. Next is
okay, so we'll just try to do this. Okay, so this will create this link. Okay, then
new node previous is equal to
new node previous
is equal to tail.
previous is equal to tail. Finally, what we have to do? Tail is equal to tail next.
Yes, sir. Tail is equal to.
Will it work? So now we have created new node with two null values. Okay, so this we have next is null and previous is null. So next is already null. Okay, so now we'll just see what we did. Tail next is equal to new node we did. Okay, so I'll just remove this. Okay, so what we did, tel next is equal to new node. So tel next is added over here. Okay, so tel is at this position. Again, we'll made new node previous is equal to tel. So new node previous is equal to tel we made. Okay, and finally what we did, we have made tel is equal to tel next. Okay, so that tel will be shifted at this position. So that will be the next position that we have. So tel will be now pointing at this position. Getting? So how we are inserting the node over here? Hello.
सर कुठे करायची?
Okay, getting how this is inserted, this node.
Yes, sir.
Okay, so this is only with the pointers. Okay, so while working on the linked list, okay, so whether it is singly or doubly, you must be very keen to understand the concept of the pointer. आता याच्यामध्ये सगळ्यात सोपं तुम्ही काय लक्षात घ्या, we have a matching what is match boxes. Okay, there are 10 match boxes which are placed in front of you. Just consider a singly linked list. Okay, so it's, every match box is connected with a small rope. Okay, so now I have to delete the last thing. I just cut the rope, that is deleted. Getting? If I have to add insert inside any one thing, I have to cut the rope and I have to attach that rope to the new match box. Okay, so that we have. Okay, so likewise we will consider that singly linked list. And similarly, we have 10 match boxes which have the forward ring also as a forward string also and reverse string also, like it is attached with the rope. Okay, so that concept you keep in mind, and that what we'll say forward and backward pointers we have to just manipulate. Okay, just consider this as a thread. Okay, so suppose there is one new node will come inside. Okay, so like this. Okay, and I have to attach this in between. Okay, so like this. Okay, so what I have to do, I have to cut its next thread. Okay, so I will do. Okay, so I will cut its next thread. Okay, this next thread will be cut from over here. This is match box. Okay, next thread will be cut, and I will attach this next to over here. Okay, this is new node. Its previous thread will be directly attached over here. So there is no need to cut because that is already null. Okay, again this next is null, so that is attached over here. Okay, and again for this I will cut this thread and I will attach this thread to over here. So that is, you just consider the concept of match boxes in your mind. Okay, so how you can put the elements, different match boxes in a pair. Getting? Hello.
Yes, sir.
Okay, so just keep in that in mind. Okay, so in next lecture we'll finish up this doubly linked list by implementing it programmatically. Also, we have doubly linked list program in our what we'll say assignment. Okay, so that will do. Okay, so that specifically doubly linked list we have to perform on HackerRank. Okay, there are a few assignments, 3-4 assignments that specifically we have to submit on HackerRank. That is instructed by your syllabus. Okay, so we'll do that practically. We'll understand, and the submission there will be on HackerRank. Okay, so any doubt in this? So can we wind up the session?
Okay, sir.
Okay, sir.
Thank you. Have a nice day. If you have any
Yes,
doubt,
sir.
you can put me personally. Okay.
Yes, sir.
Thank you. Bye. Have a nice
Thank
day.
you, sir.